If we are live, so let's go.
Yeah.
Hello, everyone, and welcome to today's webinar. So I'm Dieter, and I'll be your host for this exciting session. First and foremost, I want to thank each of you for joining us today. Today, we have the privilege of exploring a groundbreaking topic: strategies for improving relevance and accuracy with vector search. We are super thrilled to have with us an expert, Edoardo Conte, who brings a wealth of knowledge and experience. CTO at Restworld, Edoardo has been instrumental in developing innovative solutions and strategies that leverage the power of AI and vector search technologies. Throughout this webinar, we'll delve into how these technologies are transforming the approach to job searching, focusing on Restworld's pioneering platform and their use of Astra DB's vector search capabilities. We'll take a comprehensive look at the technical aspects, the challenges faced, and the practical applications of these innovations. Before we jump into the heart of our discussion, a few housekeeping notes. First, feel free to submit your question throughout the webinar. We will have a dedicated Q&A session at the end where Edoardo will address as many of your queries as time allows. This session is being recorded, and the recording will be made available for your reference after the event. So, once again, thank you for being here with us. Now, without further ado, let's welcome Edoardo. I would like to ask you, Edoardo, to introduce yourself and Restworld. We would love to hear about your background and role at Restworld. Please also tell us about Restworld's vision and goal. Spot is on you, Edoardo.
Well, thank you very much, Dieter, for your kind words, and thank you, DataStax, for hosting this webinar. I think it may be very insightful for many different architects or CDOs or any person like roaming around with their own companies and products. So thank you again. And I'm Edoardo, as Dieter well presented me. I am co-founder and CDO at Restworld. My journey actually started with a bachelor in computer engineering. Then I studied a master in artificial intelligence. It was like big data management and analytics. Then we started Restworld, and Restworld is a platform. We are based in Italy, in Turin, in the northwest part of Italy, for who knows. And we are dealing in the, we are, let's say, working in the Horeca sector. And by Horeca, I mean hotel, restaurants, and bars. So we are vertical in this domain, in this industry, and we support employers and employees to find each other. So I see a message that someone is not hearing. Can you hear me properly, Dieter?
I
Or do
can
you
hear
have
you
any issue?
perfectly.
Okay, then I'll go on. So as I was saying, like Restworld is supporting employers and employees to find each other. What do I mean by that? It's kind of a marketplace where you have business owners and HR managers on one side, and on the other side you have job seekers and workers of this industry. We are sort of a mix between a recruitment agency and a job board. So the values at our core is the human contact that we create with our clients and users, and we use technology and we employ technology as our, let's say, main engine to optimize our process and to give value to our users in a scalable way. I think I've said a few words about myself. I don't want to talk too much about it, but you can look out what we are doing.
Hey, many thanks, Eduardo, for this introduction. So let's keep going. So, what we are going to cover today. So, first, I would like to introduce to everyone. So, what is vector search? Then, Eduardo will take us by the hand and will introduce us a bit more to Restworld and to the platform they have. And yeah, you can also expect a live demo of the platform. Then, yeah, we are super keen to understand how RESTworld leverages vector search in order to improve the matching algorithm that ensures that there is a perfect match between employer and employee. So this is within the technical deep dive. And so Restworld is in production with that solution, and it was a journey. And in a journey, it's about learnings, and the learnings, Edoardo will tell about the learnings today. So it is about best practices and tips. And at the end, we will have a Q&A session. So with this, what is vector search? So what is a vector? So by starting thinking about vector search, I would like to introduce some of the terminology we use in that area. And a vector is used within the Gen AI space in order to represent text, image, and video. So what is an embedding? An embedding is actually the mapping of data into a format, the format of a vector. And in order to map that data, so this data can be an object like a text, an image, a video. In order to transform that object into a vector, we leverage so-called machine learning models, embedding models. And these models, they actually capture the semantic and the context of the object that we vectorize within the vector. The question now is, so how does it look? And here is an example. So this is an example for embedding. On the left-hand side, you see a raw text, and think about a chat bot that you want to implement that is able to answer questions based on your own context. In order to provide your own context, so what you can use there is a vector database as a knowledge store. And what you do is you vectorize all your context. First, you take your PDF documents and split them into chunks. And each of these chunks gets actually vectorized with the help of an embedding model. And then you get what you see here on the right-hand side, the embedding. So the embedding in the format of a vector, you see a lot of floating numbers. And all these floating numbers, yeah, they actually represent the vector and represent the context from the text that you see on the left-hand side. So the question is now, what can you do with that? And what you can do with that, you can use that in order to do a vector search. So vector search is similarity search. And so we all learned it in school. As soon as you have a vector space, and within that vector space, two vectors, so what you can do is to calculate the distance of these vectors to each other. And the distance is at the same time the rate of similarity of these objects. So with this, you can leverage vector search in order to find objects that are most similar to each other. And this is a technology that was used at Restworld and that Edoardo will introduce to us in a second how this was leveraged in implementing features in the Restworld platform. So with this, Edoardo, I would like to ask you to provide us an overview of the architectural design of the Restworld's search platform. First, let me stop sharing my screen so you can take over.
Thank you very much, Dieter. Let me just share my screen. Now you should be able to see it, right?
Yeah, we can see it perfectly.
Okay, lovely. So thank you very much for this introduction. I think it serves as a context for everyone, independently on the, let's say, the level of knowledge about vectors. So let me talk about here. I already gave a bit of introduction on what we do. So we work in the Eureka business. We are dealing with humans. So we have an internal team actually of customer success managers, which are a group of professionals like talking directly with our clients and candidates. So they are making this matching happen in a way, and they have their own internal platform which is developed by us, and they use it as a sort of the technology bridge between the employers and the workers. And so we exploit technology in order to optimize our process to make it, let's say, scalable and sustainable. I just wanted to give you, let's say, an overview of how our service, our platform looks like, so that we are everyone on the same page, and what comes later, it's maybe easier to understand. So as you can see from this picture, like we do have one application for the workers, the job seekers, another application for the employers, and we have this application which is called, we call it Lab, which stands for like a breeze. It's kind of funny name, anyways. A few years ago, and the CSMs, the customer success managers of Restworld, are using this application. Now everyone, let's say, communicate with the same backends and with different data stores, among which we have our operational database, and then we have DataStax Astra DB, which serves us as a vector store where we store, let's say, our knowledge representation. So this is just on a high level view of our platform.
Yeah, thanks a lot
Um,
for this introduction into the platform. So it sounds like that it is a combination of a direct contact between CSM and customer, but leveraging leading edge technology, right?
Yeah, exactly. So let's say that we have an infrastructure as base, which is the application shared by all these users. And then what we are doing, what we are trying to do right now with vectors and with this new AI technology, is to give some tools to the CSMs to explore the database of the workers. We are now at a point in which we have enough data, a big enough database of users, of job seekers, that we have issues in finding the right people for the given job offer. So we are now developing a set of tools based on AI, powered by AI, that allow the CSM, our internal team members, to explore the database of our workers, of our job seekers. So this is, let's say, the context and the challenges that we are facing right now.
Yeah, thanks a lot for sharing
I
that.
definitely. Yeah, let's say I'm gonna go much more details maybe a bit later. I can maybe explain a bit more like how we actually implemented this, which I really like think it's important to share and also to discuss with different companies, different people. And I want to focus on actually the last 2 points here, which is okay, but how do we actually create this set of AI tools? Like, how do we start from scratch? And the thing is that what we believe in is to have fast iteration. So sometimes it's better to deliver something quite fast, to go online quite fast, to design something which is not super complex, but it can give you already like a hint on how it works with your users. And at the same time, like, try to think of building something that creates a foundation for the future, so that creates some value that can be reused, that you can build on in the future, so it can be evolved in the future if it works. So yeah, these are some, let's say, design principles that have driven, let's say, our development in this direction.
Yeah, sounds great, Edoardo. And I believe, yeah, so this is really a best practice, right? To have an incremental iterative approach and to implement, yeah, smaller features and to bring them into production as soon as possible, because production is the real thing. And there you get directly feedback from the users. And yeah, you can tailor in which direction you want to go afterwards, right?
Yeah, I think I'm not saying anything new, like probably most of the people here have experienced it much more than me, or I don't know, anyways, different experiences. So these are kind of very used concepts, but I think it's useful to have everyone on the same line for what comes next, which actually is explaining how we implemented the algorithm. And I think it explains a bit why we use these as design principles and what was the final result. Sometimes, even if these concepts are quite clear, sometimes you kind of lose them, and these happen to us and happen to like to a lot of people, other companies that we know directly. And sometimes you know, like you miss them, even if they are so obvious and trivial.
Absolutely.
So I would say we can go for a very fast demo, like before going technical. What do you say?
Yeah, it would be very
Or
nice. Yeah.
okay, so as I mentioned, like we created an AI tool that supports the CSM to explore the workers in our database. So it's not so easy to show. Let's say let's try to show it, and then you can ask me any kind of question, so we can get deeper in that. So I'm sorry for this, but the interface is in Italian, unfortunately, as I was saying, not unfortunately, but we're working in Italy, so like we designed this internal platform all in Italian. And if I translate it, sometimes it gets bugged. So let's leave it like this. I believe it's quite easy to understand. So here we have a job offer. In this case, is a kitchen role for this restaurant specifically. We do have all the requirements here, like what this restaurant is looking for. Okay, and here we have the list of job seekers, the list of workers in our database, and you okay, no, this is already, let's say, let me start again. This is the beauty of the live, like everything gets breaking all the time. Let me start again with another one. Let's see. Like if I go with this one here, I start from scratch. So here we do have this job position again, like it's a similar one for the same restaurant that we've opened in the past. Here you can see that we have actually. Uh, I'm sorry, but this is again like beauty of the life. Things okay. Hopefully this time, yeah, we do have 100,000 users in the database, so it's getting complex for the CSM to actually find the right ones. Okay, so what we implemented was this algorithm based on AI, where you can see like the CSM can tune some parameters that we've built with them. So we listened to what they needed and what they needed to control of this algorithm. And basically, yeah, you can have some, let's say, yeah, parameters. I will go in details, like if you want, but basically, like it tunes the semantic search on our vector store. So let's leave it like this, like default values for this kind of research, and let's see if we find anything. But the main concept is that here we are extracting, and here we have a list of 100 candidates in this case. So we're extracting a list of 100 candidates that have been shortlisted in the past for similar job offer than this one. So these candidates here, you see that they have applied for very similar role. Like, okay, maybe you cannot understand. It's in Italian, but it's very similar. So they are all in the kitchen, and they applied in a very like close restaurants with respect to this one. So they are very close in terms of distance. So this is the kind of algorithm, and with just 2 clicks, actually, you can have some semantic search on your database based on what this job seeker did in the past. Um, I hope it gives a hint of what goes on behind the scene, but like you can ask me any question if you need to get
Mm.
deeper. I'm available even after this webinar.
Yeah, very, very nice, Edoardo. Thanks for sharing that. And so what is the main value of this new matching algorithm? Is it that you have more matches and better matches, or what is the main value?
Yeah, that's actually a very good question. So, as you mentioned, like we went online 1 month ago, something like that. So it's kind of recent this release. So we don't have some quantitative measures like real ones right now. We've run anyway some qualitative analysis with the CSMs. So it's a team internal to our company. So it's very easy to run qualitative tests, and we can already see and we can already say that we expect to have some sort of like 5 times improvement in the conversion rates of our internal workers of our database, which is our added value. Actually, the added value of Restworld is that we have candidates, we have job seekers in our community that you cannot find anywhere else. And with this algorithm, we are improving our retrieval conversion rate of 5 times more
Hey, that's
around, let's say, out of our qualitative tests.
Yeah, sounds like a great success, and yeah, I believe so. Restworld is a startup company, right? And so there are investors, and I'm pretty sure they love this innovation, right?
Yeah, that's quite funny actually, because we are in fundraising right now. Like any startup is always fundraising, but let's say yeah, we are in the middle of fundraising, and we're talking with venture capital, and yeah, like this year we could really like give a key. Let's say we had a kind of key in the development of the products, and we can actually sell, we can actually communicate that we're not doing AI, like we're not really like using creating machine learning algorithms. So I don't want to like I don't want to lie to anyone, like we're not doing that, but we using tools, we're creating tools to optimize our process which are powered by AI, which is a big difference. But today, like there are some very mature tools that allow us to create business values just by using them and by exploiting them with our first party data. And this is what we are creating, this is what we are selling. And yeah, I would say venture capital investors really like this approach.
Mm. Hey, that sounds fantastic. And Eduardo, yeah, we got a question from SoulMind. I believe this is what we are going to address in a second when you dive deeper into the matching algorithm and into vector
Definitely.
search. So let's go
Uh,
for that.
I don't see the question. I'm sorry, because I have only one monitor as of now. Uh,
Yeah. So
like
the question is mainly how it works in detail.
how well,
Yeah.
that's that's a good question. I'll get to that. I'll get to that. Yeah, it's kind of, yeah. Probably we should have done it earlier. But anyways, I'll get to that. I'll go into the details here. And okay, let's just start then with the with technical implementation. I want to give a bit of context here, which is okay. We're gonna focusing on lab as I showed to you. Like the application, the final result is gonna be in that application. But what we're doing is that we are creating a knowledge representation of our job position. So as I mentioned earlier, this is a marketplace. You can see it from this picture. We only focused on the job positions that we can characterize and that we can manage. So we decided, instead of focusing on both the workers and the job positions, we only focused on one entity. And this comes again like to the fast iteration methodology I just highlighted before. So just start with something as easy as possible, and we decided to start with the job positions only, and we wanted to create a knowledge representation of that data. And this is where let's say this is where Astra DB and all these new generative AI text embeddings solution come into place. So we just took the job positions data that we had. By job position, I mean like, well, we're looking for a cook with this number of years of experience. Is going to be doing, or she's going to be doing these shifts, and the salary is going to be this, and that, and so on. All these requirements information, which is quite rich, and we characterized it pretty well. So we create a textual description out of it with all the prompt engineering of the case. We translated it automatically with DeepL. DeepL is just a tool, like you can choose another one. We just went with DeepL. So it's automatic translation into English, because we realized out of the documentation that we found, we didn't really test it with numbers, but most of the documentation of some text embedding model, like we used OpenAI embeddings in this case, just for simplicity. And most of these tools, most of these embedding tools, like they just say they work a bit better in English. So we just said, okay, let's translate all the text in English. The translation of DeepL is quite good. And we are using OpenAI embeddings. Again, one of the reasons is for simplicity, because we were already connected with it. And in the future, we can always switch it with another embedding model if we see that improvements are that the performances are improving.
Yeah.
So this is, let's say, the overall structure and how we created a knowledge representation of our job positions.
Thanks a lot for sharing that. And really, Eduardo, it sounds like you proved that the hottest new programming language is English, actually, right? And yeah, so we worked together on that. We accompanied you in that project, and I believe that was also a learning, a bit trial and error. Can you elaborate on that a bit?
Well, that's actually actually funny, like because it's actually kind of true in a way. Um, so I was just like thinking about English is the new programming language, and it makes a lot of sense with the new tools that we have today, and with all the evolution that we can foresee in the next years. Semantic search, all these kind of applications or chatbots. Um, but yeah, the assumption here is that we found with DataStax a partner, and I'm just saying this honestly, very honestly, like we work together into finding a solution, and we just need to be clear. Let's say that this year has been full of changes, full of innovations in this space of generative AI. Now companies and people are trying to understand how to actually apply them, how to apply all these tools. And then, of course, it's trial and error, and it's again fast iterations. Just go fast, just develop something which is easy, not overcomplicated, and just see if it works and if it's promising for your company or for you as a person to push in that direction, if it creates enough value. And yeah, we actually designed this solution together, and it's always like cool to work with people like at the cutting edge of technology, which understand like what's going on and have some hints on the next direction, let's say the next steps to take on the in this direction.
Yeah, thanks a lot for sharing that. And you already spoke about the embedding model that you chose, OpenAI. So there is such a lot of technology in that space available, right? So
Yeah,
any other libraries you can recommend or you have used there? Anything you would
yeah,
like?
let's say, yeah, it really depends on the application everyone has. And I would say we personally use OpenAI embeddings, and we tried a couple of embeddings model from Hugging Face, which is a super great provider. And but we never used it in production, and we don't even have some now numbers to evaluate the performances. So we're kind of not very like let's say sophisticated in measuring the performances of embedding model. We are just trusting the documentations and the benchmarks that these models have with some, let's say, contextual data. But yeah, there are like a tons of different models, and new ones are just getting out. And but yeah, Hugging Face is a great provider. They have tons of models. So yeah.
Thanks a lot for sharing these insights.
No worries. Well, I would say maybe now it's the time to go to the algorithm itself, which is probably interesting, probably curious, probably you guys already know it. It's not rocket science actually, but I think it may be useful and insightful to really understand how to create solutions which are easy and which are straightforward, and they can be very, very efficient. So we used a sort of collaborative filtering algorithm for our recommendation system. As I mentioned, the context is that we have a job offer and we need to find workers and job seekers that can be interested in this job position here. So why did we do this? I already anticipated a bit. So we are exploiting the characterization of the job position, which is in our hands, and we are recommending workers based on their history on our system. So based on what they did earlier in their history, and to which other job positions they have been shortlisted or even hired. So how do we do this? Like, let's imagine that now we created this knowledge representation, this semantic representation of our job positions in this embedding space. So they are stored in Astra DB, in the vector store of Astra DB. So here you can see this very ugly representation of the job positions on these, like, let's say, two-dimensional space for simplicity. And not design. I'm not a designer, and you can probably see that. But anyways, like, the idea is that we are considering the job position one. So this is the job position for which we want to find similar, or let's say fit workers. So what we do is that in this case, we extract the job positions that are very similar to these ones, are semantically similar to these ones. So for example, in this case, we do have job position 2, 3, 4, and 5, which are some job positions that we've managed maybe in the past, like 6 months ago, 3 months ago, 1 year ago, which are very similar in the characterization to this one here. And then what we do, just afterwards is that we're saying, okay, for those job positions, let's find the workers, and here I just depicted 1, 2, 3, 4, and so on. Just find the workers that were in some way associated with these job positions here. And my assumption here is that, okay, if these workers, if these job seekers were associated with these other job offer, which are now similar to JP1, then probably in some cases they also can be interested in JP1. Now, um, what's the feature, the reasoning, the assumption that actually was really, let's say, appreciated by the CSMs themselves, so by the users themselves, is that we're not considering the data of the workers, because we have a huge issue in our platform, in our system, is that sometimes with a consistent percentages, let's say the workers are not filling in their own data. They're not like having complete profiles. So here we're not really exploiting the data of the workers, but we're only exploiting the history they had with our system. So yeah, this is, let's say, a high-level overview of the algorithm, and probably you guys already know it. Can be of inspiration to someone, but open to question.
Thanks for sharing that, Edoardo. And it sounds like, yeah, so the most important asset actually is the data that is owned by Restworld, all the workers' data and the job positioning data. And it is also about having curated data here, I believe, to get best results when you do such a vector search in order to find similar job positionings, right?
That's actually perfectly right, and this is what we believe in, which is um, this may be arguable, but the added value of a company, of a business, of a product is the first party data. This one of the added value. Let's say it's not only that, but don't want to be simplistic here. But anyways, like one of the added value is the first party data that the company has, that the product has, and semantic representation of this data is a great tool, I would say, to exploit the information that you already possess, that your company already possess. And well, yes, like we exploited the fact that our CSMs have worked for 40 years into creating the job positions in our system with our clients, so they are very well characterized. And all these workers have been shortlisted by our own CSMs, so they have been interviewed, most probably assessed by our CSMs themselves, or even interviewed by our clients directly. So we make assumption on what happened to them in the past, and we exploit the interactions that we had for all these years, that the efforts that we put in our system for all these years. And this is something that we only have uh, in terms of these people and these job positions here, and we are exploiting exactly that.
Hey, that sounds fantastic, Eduardo. Yeah, I believe with this, yeah, the matching algorithm, how it works, we gained some great insights from you on that. And yeah, now it would be very interesting what role actually Astra DB played in that whole scenario. So what was the value for you? What is your experience with this technology?
Well, that's actually a great point. We mentioned it earlier, and I think I will highlight it again. It's not on this slide, but I will highlight it. And before Astra DB, there's DataStax, and DataStax has been for us like a great partner. So they actually really believe in working with the companies, with the businesses to deliver some value. And this, I think, is something which is not trivial, which shouldn't be given for granted. It's not, and that's DataStax. Then Astra DB is a great product, and it's one of the easy choice if you need to choose for a vector database, because at least for us, it provided us like real-time database based on Cassandra, so battle tested, and that's okay. Everyone knows Cassandra. Everyone knows like for what Cassandra is used. Then it's serverless, and it provides you high flexibility. So today you can try an MVP. It may work, and you can scale. It doesn't work, you switch with another MVP, another product, another proof of concept. So serverless is giving you really high flexibility, and this actually connects with the zero operations. So you actually don't need to set up anything. So you just go on the dashboard, you set it up, and like in few minutes you have an operational database that you can use, and it's scalable, and it's really scalable. And for us, it's for the future because we don't need scalability right now. But let's say as soon as the data grows, you're sure that your partner is already ready to take that workload without you doing anything. So yeah, this is just to summarize like why we chose Astra DB and why it's a great solution for our use case.
Thanks a lot for sharing these experiences with us. And yeah, as always, when we are on a journey and working on a project, right, it is also that we face some challenges. So, can you share a bit about the challenges that you faced within that project?
Yeah, challenges are always great, like they are interesting. They give you something to think on, and nothing is perfect. Nothing is always like as easy as everyone tells you to. But anyways, like here I just wrote down like the two main challenges that the only challenge, actually, it's only one. The only challenge I've experienced in this journey, which is filtering the data according to different, let's say, fields. So what do I mean by that? Like we're using vectors to let's say extract the most similar job positions. Okay. So as also Dieter was showing to you, like you can just go into a point in this vector space and you find the closest ones. Okay. And those are the semantically most similar ones. You find the closest ones, but sometimes you want to exploit some categorical information of your data, for example, or some textual information of your data, which is, for example, but I just want the job positions of this type, okay? And this is, let's say, a Boolean field, so I want to exclude all the other ones. So in that case, it's not, let's say, impossible. It is not, of course, but you need to take some solutions. You need to design some solutions which are, for our case, was to, let's say, synchronize our own operational database with DataStax, with Astra DB, also for these fields. Okay, so these fields were synchronized with the Astra DB, and we needed to keep this synchronization for updates and whatever. And then we exploit the storage attached index of Astra DB and Cassandra to index that data as well, so that we can have some optimization in the querying performance of those categorical fields. So this is the challenge I see. So whenever you include new data sources, you need to keep them synchronized for all the data you need. So if you need to filter based also on other data, you need to have that data, those fields directly in the data store. If you don't want to design other like very complex and messy solutions sometimes.
Thanks for that. And as usual, so we learn from these challenges. And hey, Edoardo, would you be so kind to speak about your learnings and share with us the best practices?
Yeah, I'll try to give my thought on this, and of course, like that's my opinion. I'm open to discussions, and I'm more than glad to have discussions with you. So I get back to the same point I kept highlighting for the whole webinar, which is fast iteration, which is a bit more profound than that. And we have this saying in our company, which is that sometimes, because it's not all the times, but sometimes having something is better than having nothing. And this means that you can design a solution which is not creating a disservice for what you already have, and this is the assumption. And this feature can only create something a bit more, and that bit more, now it's up to you to evaluate it and see like if it creates enough value, and if it's worth for you and your company and your goals to keep pursuing that path. And in our case, we decided to have an easy solution because it's not very complex to implement. It's articulated to put it in place and to have some results and everything, but it's not. It can be more complex, definitely. But at the same time, this solution works as a foundation for the future. So we can have something online which is tested, which is used, and we have an immediate feedback of it. And at the same time, it can be improved in the next months. It can be built on, so we can create some knowledge representation for the workers, for example, and we can start playing around with that as well. Semantic search, similarity search with the actual worker data. So what we created is just a foundation for the future. And my last hint, which is my thoughts, and I think it's really important, is to LLMs are great, generative AI models are great, and I believe they create immediate value most of the times. But the biggest value they create is when you combine them with your first-party data. And one way to exploit them, which I think is also the greatest way we have right now, uh, is to use some knowledge representations, to give knowledge representation to your data. And using vectors, you are creating a semantic knowledge representation of your data. And then this behaves as a context for LLMs and any other enabler to interact with the user and to provide value to your users.
Great. Thanks for sharing that. So, yeah, it is all about the data and get most out of the data. And you can do that by being innovative, trying out things. Absolutely. And yeah, so we would be very interested in the future and beyond. So, what is in front of you? What do you have in mind as next features and maybe Gen AI powered features within your platform?
Yeah, it's funny. I took this slide out of the deck investor, and I mentioned earlier about the fundraising, and we are now. I'm just telling you guys what we are telling to venture capitals and about our plan and everything. So right now here we are here. So these two features are in staging. Let's say we are running some QA right now. So we have semantic search on the workers, and we have similarity search on the workers. So this step here is about creating a tool of features based on AI to give to the CSMs in order for them to navigate through our data in an easier way. And then here, like we are now designing and we are thinking about it, like we are, yeah, already in design process and proof of concept process. An assistant, an AI assistant, you can think now of a chatbot for the workers in order to support them in completing their own profile. So inserting all the missing data, because I mentioned that that's one of our challenge, that not all of them have all the data fill in their profile. But then here it gets cool. Here it gets really cool because we are now exploiting all these contexts that we created in order to provide to the users automatic interview questions, interview automations, so we can execute interview and assessment automation on the workers. And why is this cool? Because the interviews that we're gonna submit to the workers are going to take into consideration the context of the job position for which this worker has applied to and the context of the worker. So what kind of requirements is maybe missing, what kind of requirements is really unknown or it's not really certain, and so on. What other people did in the past that really worked out for similar job positions, and so on. So we can really be fancy about exploring the data. So my point of view here is, let's invest in creating this knowledge representation first, and then you can be really fancy on how to navigate through it, and it gets really easy. And then, of course, like the final step would be to create an intelligent agent for the CSMs. So now imagine all these tools, some based on AI, some not, which are inside our internal platform. And now we have an agent, an intelligent one, which communicates, which is driven directly by our CSMs, and it executes actions on our database. It navigates through the data, it submits interview questions, and it simply provides the CSMs like a report with the results of all the workers that may be fit or not for given job positions and why. So this is, let's say, the vision that we have. And as you see here, like we are really talking about process optimization. So we just take our process and we optimize each single step. And here it's really like heavy on AI. And AI is what really will guarantee us to take process optimization to the next step.
Great stuff. So a lot of innovation ahead of you. Sounds great. So you are going to use chatbots in order to improve the data quality, right? And as we have learned from
Yeah.
you, so data, it's all about the data that you have and to get most value out of this data. So with this, actually, so I believe we are at that stage to answer questions. So by looking at
Yeah,
these questions,
I'll get back to the. If you allow me, I will stop sharing. Am I right? Right? I could be. Okay, I see you again. Okay.
yeah, I can also see you again. It was a small window with the video for us. So now I share my screen again. Yeah. So I have a look at all the questions asked by the audience, but actually I cannot find any question that we didn't answer, that you didn't answer in the session. So I believe we can continue directly then to the next slide. So yeah, so we have learned a lot from Edoardo, and so that data is the most valuable asset, and to get most out of their own data, out of their own context, each enterprise is, and by leveraging Gen AI, LLMs come into the picture. And in order to work with their own context, there are two main approaches. So, one approach is to train the large language model with their own data, and then all the data is retained within the large language model. Whenever the data changes and need to be updated, you need to retrain your large language model again. Another approach is retrieval augmented generation. And this approach leverages Astra DB, leverages a vector database. It is used as a knowledge store where you store all your context, all your documents, your product descriptions, service descriptions, all that gets vectorized. And then by executing a similarity search based on questions that customers would like to have answered, the similarity search takes place and retrieves the context out of the knowledge store and provides that to the LLM. So you can use the LLM like it is and provide the context in the prompt. So that is what I would like to add to our session today. And if you are excited by the things we have learned today, so it's easy to get started by taking a picture from the bar chart here on the right-hand side. It will navigate you through our docs to the Astra docs. And within the docs, there are a lot of getting started guides. There are prepared Jupyter notebooks available in order to try out vector search, even to try out vector search in combination with images, vectorizing images, but also how to implement chatbots based on retrieval augmented generation. So with this, I believe we are close to finish this session. So as we bring our session to a close, I wanted to extend a heartfelt thank you to everyone who participated today. A special thanks to Edoardo Conte for sharing his expert insights and experiences with us. The depth of knowledge and practical examples provided today not only shed light on the complexities of vector search, but also opened our eyes to the vast potential and possibilities in this field. To recap, we delved into the innovative strategies and technical advancements, exploring how they enhance relevance and accuracy, particularly in the context of job searching in the hospitality industry. The practical applications, challenges, and future perspective discussed today are valuable for anyone looking to leverage these technologies in their own vectors, own sectors. For those of you seeking further information or resources, please keep an eye on your email for a follow-up message from us. This will include a link to the webinar recording, additional resources, and answers to some of the questions. And thank you once again for joining us today. We look forward seeing you at our future events. Have a wonderful day or evening wherever you are, and goodbye for now.
Thank you, Dieter. Thank you for having me here again, and goodbye to everyone.
Thanks a lot, Edoardo, and see you soon. Have a nice
Bye
evening.
bye.
Bye.
Thank you, you too. Bye bye.